with you over at Whitney and whatnot, and it's so glad. You've really boosted the whole vibe here in New York City with your Chicago windy blusters. It's so good. I'm glad we talk about a great man like Mr. Fuller. And welcome very much to Conversation. A great pleasure to welcome to the program Martin Brennan. He's in from Chicago, and he is billed as a Buckminster Fuller educator, and he's very interested in Buckminster Fuller, and we both would parenthetically say we're talking here in early July of 2008, and there's been a major show opened last week or so at the Whitney Museum here in New York City, celebrating the memory and the contributions of this great man that we both agree and others have, and we were just reminiscing Buckminster Fuller. And we're going to be talking about that and other matters. And Martin, welcome so much to Conversation.
Thank you for having me, Howard.
It's been good talking to you, ad lib, as it were, as we went to different events over the last week or so. And now it's good to have you on the program.
Thanks so much.
I wonder if you could share a little bit of your own background, please. That's what we do here. You're born and raised, educated a little bit. And then we'll talk about this man, about the show, and that kind of thing. And you're going to demonstrate some things that you put together. But talk a little bit about yourself personally, born and raised, educated.
Chicago. I met Fuller for the first time at the Expo Dome in Montreal.
Oh, 67?
Yes. My brother was a protocol guide, and his job was to take VIPs through the pavilion, so he took Mr. and Mrs. Fuller through. And my brother had studied with him in Carbondale also.
Oh, really?
Yeah.
That was at Southern Illinois
Right,
University.
He was headquartered there, right. And he's most famous for the Dome.
Yeah, maybe most famous.
Most famous for the Dome, but that's only part of the great work that he did. He's considered an architect, but really he didn't set out to design a dome. He didn't set out as an architect would to design a new kind of building. The dome is just a result of his discovering the actual mathematics that nature uses.
Yes, I know.
And it started way back in 1917. He was in World War I. He was in the Navy. And he was on a ship, he tells the story, and he was looking at all the froth behind the ship, the bubbles. And he was thinking there must be hundreds of trillions of bubbles.
Yes.
And he was wondering, how does nature do that if she uses conventional square and cube mathematics? Because the mathematics we know today, XYZ coordinate, cubic math, based on the Greeks choosing the cube as one unit. And it turns out the Greeks were wrong, because the Greeks chose the cube.
Okay, you got a thing here, and let's give him a little time to come with the camera. And these are things that he's fashioned and put together with straws. I think it's done with things you could have in the kitchen, and everything.
This is just,
rather than making it some big complex thing, it can be done at a very simple level, and he's put that together. We'll get into that. But he's demonstrating here now, and you can come in on him, and he's got in his hand, maybe you could explain it then, what you've got there.
This is a model of current mathematics, and this is why nature doesn't use the cube, because it's completely unstable. It's the most unstable structure, and yet it's the basis for current math, which is XYZ coordinates. So Fuller said to himself, let me try to see if I can discover what nature does. And I mean discover rather than design. The Greeks designed this. He discovered, like you would discover the Grand Canyon.
Yes, right.
He discovered how nature builds.
Right.
So he said, I just read recently.
At a molecular level even. Or
exactly, at atomic level.
Yeah, at atomic level. Okay, go ahead. I'm sorry to interrupt.
No. He said, it must be that nature uses triangles, because they're self-stabilizing.
Okay, now you've got a triangle there.
The triangle is self-stabilizing. The square is not. The square is completely unstable.
Okay. Yeah, right. Okay.
So he got rid of these and started with the triangle.
Okay, yeah.
And then he wondered, what is a three-dimensional version of the triangle? Because this is a three-dimensional square.
Yeah.
A three-dimensional triangle is a tetrahedron.
A tetrahedron, and that's like a pyramid.
A pyramid has a square base and 4 triangles.
Right.
This gets rid of the square base, and it's just the 3 triangles.
Okay, right.
So it's very, very stable.
It is indeed,
You can see this is just light straws.
And that is what is called a tetrahedron.
Tetra means 4.
Yeah.
Hedron means face.
Okay, and that was known, that terminology was known, say, in ancient times
yes.
and everything, right? Archimedes or something?
Right. It's part of the Platonic solids.
But had been overlooked in terms of the modern experience where people are looking at the cube.
Right.
Like
well, it's still overlooked in terms of mathematics. We're
Okay.
still teaching incorrect mathematics.
Okay, as far as nature's pattern.
Well, right. It's what nature actually uses.
Or universe's pattern, perhaps. Yeah.
It's true anywhere in the universe.
Yeah, okay, right.
Exactly.
A big concept.
Absolutely.
Yeah.
And it was new then and controversial then, and it's controversial today. It's very difficult to get schools to teach this. And yet it's true mathematics. I call it natural mathematics, natural architecture.
What did he call it?
Synergetics.
He called it synergetics. If I may, synergy is the behavior of systems unpredicted by the sum of its parts, as I understand synergy. Now, that's a different kind of thing. I'm thinking in terms of systems and so forth and everything. But why would it be synergetics? Is it geometric? It's a geometry.
Well, it begins very simply. If you take 3 oranges.
Okay, boys and girls, now watch this.
You take 3 oranges off the table, and they stay planar. They stay flat. No matter what you do, it's always flat. So that's extraordinary to begin with.
Yeah.
So nothing in the 3 separate oranges tell you that that's going to happen, that they're going to stay flat.
Right.
And nothing in the 3 tells you that it's going to have a nest to make a 4th.
That's your tetrahedron.
That's your tetrahedron.
Yeah.
So this is a system you use to indicate where balls are associated. So we go to the center of each ball, to the center of the next one, then to the center of the next one. So there's a ball here.
And then you hold it up, you got the tetrahedron, right? You can see that.
There's a ball here and a ball here. Yeah. So this is the simplest shape. And this is what he started synergetics with.
Okay.
He used this tetrahedron as 1 rather than the cube. The cube takes 8 balls, but the tetrahedron only takes 4.
Okay.
So when you use this as number 1 in synergetics, everything that follows is all whole numbers.
Okay.
The reason we use pi and constants and fractions is because we're using the wrong system, and we need fudges to make it work.
That's really interesting. Yeah, okay.
It's that basic. Then he discovered that, well, really from the Platonic solids, it was known, as you said, it was known earlier, that there are only 3 structures made of just triangles. The tetrahedron that we just saw.
Now give it a little slow.
Okay.
And this is a thing.
You can make these at home.
Again. And that's made with marshmallows that I'm going to put in my cocoa when we're done with this,
Marshmallows and toothpicks.
And there's a thing I want to demonstrate now. Can I show this now?
Yes.
This is a picture. Come in on this if you come in tight. And then because there's a funny little tail tail attached to this. This is a young man. You demonstrate this to a lot of people. You're an educator. And this is a young man. Here, let me get it down like that. Okay. And there he is, and you're demonstrating this thing. And there you got the oranges, and you got the marshmallows, and you got the things like that. And why don't you tell me about this picture?
Well, a funny thing happened. I was teaching that.
Funny thing happened on the way.
My general exhibit, I used to install the exhibits prior to Fuller's lectures in the 70s and 80s.
Good for you, yeah.
And they would be up for 6 or 7 months before he came, so it was very helpful for people because it was very difficult to understand, although it's terribly simple.
It's simple at a certain level. And
and yet you can't get any simpler.
Part of that's because you're overcoming the incorrect way in which we're figuring things in the normal course.
Right, we're fighting the bias and the convention of
math.
The
conventional wisdom, they would call it.
So this is my general exhibit, which is used for children all the way up to physicists. It's the same exhibit.
Yeah, right.
So, but in the children's exhibit, I use the styrofoam balls and toothpick models, or ping pong balls and tape, or these models. But with the children, I decided to use edible models. So I use
marshmallows,
donut holes, round spherical donut holes, cereal. And this child is playing with chocolate malt balls and gum balls. So the kids would put three chocolate malt balls on their hand and say, this is just a planar. And then if you add one more, you get your tetrahedron, and then they would be able to eat it.
A hands-on thing.
Hands-on, but
in the mind,
they'd have to understand it before they ate it.
Yeah, right.
So a teacher came up to me at the end of the 3 days, and she said, I love the exhibit. She wishes, as everyone says, why isn't this taught more?
Yeah, right. Thank you. Yeah.
And she said, but why do you have the children eating the exhibit? And I said I want them to take it home and digest it.
Oh, that's really funny.
Well, actually, it's what I really meant was I want them to remember it.
A double entendre.
They
yeah,
did,
right,
yes.
right. Yeah, that was good. Yeah, that's
Right.
good. And that's a picture you brought in, and that's really grand. You're demonstrating it with common things, and these ideas can be conveyed in an educational way with things that are just in our life. We could. You know what I'm saying?
Exactly.
It doesn't have to be all
Everyone knows
kinds
what
of
a pile of oranges looks like at
Yeah.
a supermarket.
Right,
It's a model of synergetics.
Okay, right, okay, that's true.
And when you see the oranges pile, the grocer didn't carefully line them up in triangles. He threw them in.
They just ended up that
right.
way. And so does the molecular structure of so
Exactly.
much of the universe.
Nature uses the most efficient system. That's
really
how
it.
he discovered it. She must use this. Because
Well, now,
it's
had
most
anyone in ancient times, Archimedes or any of those people, discovered this and presented it, and then how did it come
Well,
that we
they had-
came to live
they
in
had-
a cubical world? Was that to set up the cubicle desk space of corporate America or something? You know, cubicle corporate. How did we end up with that? And
You're always
what?
getting a chance. You always love it to put a negative tone on capitalist America, no matter what the subject is.
Not really. No, I just think the model where you say we got a model and you got something new. And Fuller was he was an anticipatory design science advocate.
Right.
That we do not have to try and change people's minds necessarily. What we do is we have an environmental context that we do through good design that makes the good able to come out and to benefit, rather than trying to exercise people to be good.
That's exactly
which a lot
right.
of the time is wasted.
Don't try to reform man. Try to reform the environment.
Yeah.
He made the analogy once of when you're on a superhighway, when it curves, it's already banked like this,
Yeah.
so it's effortless. The driver doesn't even know that he's being self-driven, automatically driven. That kind of thing. So he's a big proponent of that. Yes.
Yeah.
So
but he did talk about a qualitative transformation that's going on and so forth, particularly in his later life. He addressed the system that we've inherited on outdated principles that are getting in the way of good design. It's worth mentioning maybe now, Smalley was his name?
Yes.
And the invention of a molecular structure that was discovered carbon-60, which is a basic structure, molecular structure, and is going to become the basis of all IT beyond the silicon chip. It's got properties and efficiencies that are beyond Moore's law and so forth. It's going to be the basis of the internet. So it has great practical application.
Absolutely, it's beyond
as we look ahead.
It's beyond the.
What is that? About 5 or 6 years? That's going to kick in, or something.
I would say that.
Yeah. Okay. Anyway, just mention that.
When you just said it's going to be used by the public in a certain number of years. Bucky told this wonderful story. He had written, when Einstein came out with E equals MC squared, Bucky wrote a magazine article about how it would affect the average person's life.
Okay.
So Einstein called him and said, would you come over to see me?
Yeah,
he lived on Riverside Drive here. And Bucky was only, I think, around 30.
Yeah,
and he went into his study. He was very nervous.
Yeah.
And Einstein said, he heard him describe the synergetic. Einstein said to him, young man, I had no idea that any of my ideas had any practical ability, or a practical application.
Yeah, right.
Stunning thing.
Yeah, and he was very impressed with Mr. Einstein and that visit and everything.
Yes.
And
well, his friends were Firestone and Walter P. Chrysler and all that kind of thing.
And it might
but
be,
Fuller was an average guy, he said.
Yeah, that's
I
something
agree.
important to do that.
We talked
he
about
wasn't, because we have this idea of IQ and so forth, and that some people have a great mind and all
every
that.
child's born a generalist. They're born with a very high IQ.
Thank you.
And they get into school, get compartmentalized, and they lose it. But he said he was not a genius. He was just an average guy.
And he made the point that he was able to accomplish so much, and so could anyone. Who could, it's not the thing of a certain genius type. We talk about genius. We celebrate them. Our whole system, in a sense, is star-studded, or we're looking for the stars, whether it's in entertainment or in physics or in anything. Or if you're looking for, it depends on your purpose, the purpose to which you put a way of looking at things. And if the purpose is to hit a little white ball into a cup 400 yards down the green, then that would be a Tiger Woods. And Tiger Woods can perform but there's millions of people playing, but they don't, that's another thing. That's a democratic thing, but people aren't interested in that. They want the stars.
Exactly.
And then they want to do that, and that informs our economics, that informs our thinking and so forth to an inordinate degree. And he made the point that he was just an average, intelligent person who had begun the process of thinking things through.
Well, he decided back in the 1930s he had some terrible business decisions and was broke in Chicago, and he decided he's going to devote his life to see what he as an individual could do for humanity.
Yeah, right.
And that was his
50 years. He thought 50 years out, I think he was thinking.
Yes, so he went off on his own direction and discovered all these things which he would not have done if he had stayed in a conventional life. So it was an extraordinary life.
But he did have a great. I saw some film they had at this wonderful show that's at the Whitney now. We mentioned that now. We'll come back to it. Maybe it's going to be at the Whitney. It opened last week, and it's going to be until September. And at that show, they had film clips of him when he was a young man, and he was very, very quick, and he was very alert, and he had a little thing about talking about geometry. He said, Mr. Euclid notwithstanding.
Exactly.
I mean, he was very clever.
Right. Well,
and
this is Euclid, right?
Yeah,
so.
right. And he was, he was very clever, and he had a great number of friends among the artists. He lived in Greenwich Village. He was an amazing person. I think, in a very real sense, having been able to take the measure of a whole lot of our thinkers from, from ancient classical times right through to modern and all that sort of thing, and being interested in tracking a lot of the. I think he was perhaps the most relevant, intellectually relevant person in the history of mankind, which is a little bit of a statement that may be over the top, but I don't know who tops him in terms of giving us clues and practical applications that have relevance toward our arriving at a proper operating manual for Spaceship Earth, another term that he coined, and that we don't have that yet. The institutions we've inherited out of history are not in sync with what the future requires, a major period of transition. He's given us key issues and key thoughts and perspectives that are going to help mankind make that transition if we're able to do it. He wrote a book called Utopia or Oblivion, with weapons of mass destruction that can now, our species lethal, and with a tremendous unutilized capability to bring life support to the people and the ecology of the earth, that we have that capability, and we're still muddling through with outdated ideas, and he took exception to that, and he did a lot of work toward that. I think there's a claim to be made. He was maybe the outstanding, not least Time magazine says the outstanding people of the century. He might be the outstanding person of the human experience in a very real sense, possibly.
But he's very understandable.
But he's very ordinary. Just
but
ordinary.
His books are understandable. At first you're put off by the super intellect of it, but no, it couldn't be any simpler. The synergetics certainly can't be any simpler. But he was saying, yes, an individual should take the initiative and do what needs to be done for humanity. But all of his programs, all of the work he did was based on what he called design science.
That's right.
And that is finding the laws that nature uses and applying them. So that's what he did with all of his work.
And to do it anticipatorily.
Anticipatorily. In other words, anticipate future needs.
And it all came out of his thinking. The artifacts would come out of his thinking, which came from that. So the geodesic dome, then, which he became famous for, was the most efficient way to enclose space.
Well, a sphere encloses the most space with the least surface. So if I can explain how the dome works.
Please do.
Because everyone is familiar with the dome at Epcot.
Yeah. Well, if I may, everyone was then. And if you look, if I may, just a little aside, in 1967 or in that period, 69, call it the 60s, the culmination of that, where there was a huge change going on in the world. It was felt everywhere. And if there was anyone who was a representation of that, in a comprehensive way in which people are comprehensively significant and so forth, he was probably more than any other single human being, was the epitome of the spirit of that time.
He certainly was. At the show at the Whitney, there's a videotape of him talking to hippies. I was a hippie. I'm still a hippie.
Yeah, well, all right. But and then the thing, what I'm trying to make a point in a certain sense is that period was a major period, and people who've been in the saddle of political power and that sort of thing following that moment when that was going on. It was all over the world. There was a magic kind of thing going on, and we could maybe discuss what was it that was happening that was being felt by so many people. they looked at with great chagrin by the leaders who, many of the leaders who followed, and they thought of it as just a licentious time of sex, drugs, and rock and roll and irresponsibility, and it was a terrible thing, and thank God we got over that. And that period, it was Vietnam, Martin King, voting rights, democracy, all these things were in the, coming into the fore. But that is a time to celebrate, not a time to get over, because we're going to recapture the spirit of that, because there were things going on in the zeitgeist or in the spirit of the age that are still relevant now, and things we have to recapture rather than eliminate the spirit of that age that's now about 37 years old. That's one of the points I would want to make.
Exactly.
And there's a lot of people who can cotton on to that idea that there was something very important. If we could get at it, we might be able to help us make the transition that is still needed, because we still have weapon systems that they're heading that are species lethal. We got to keep that in mind.
Well, he said
and there's a reverse pattern to that, which is on the living side, that we ought to capture, and he would help us in capturing that other side of the transition that we're in the process of going through now.
He said we've reached this marvelous technology primarily from weapons planning.
Yeah, it's always been weapons.
And we
led the research.
Without realizing it, now have the capability, we've had for years now, capability for everyone on the planet to live a sustainable life.
That's the reverse side of the destructive scenario that is also there.
Right.
Still.
So he called that livingry as opposed to weaponry.
He coined that term.
He coined the term livingry, correct.
He didn't have a word that was there. He coined one.
He coined it, yes.
Yeah. Okay.
Well, actually, when he used to use the term synergy, he used to ask audiences in the 70s and 80s, anybody know what synergy is? And no one knew.
Nobody put up
But it's
their
very
hand.
popular now.
Yeah. Oh, yeah. It's on every ad agency's lips.
Yes, exactly.
It's been captured as a thing. You know, it's behavioral systems predicted by the sum of the parts, operative in the structure of universe.
Exactly. You can't tell from looking at a part what role all the parts together are going to play.
And yet that's and he used to talk about comprehensive, be a comprehensive, he coined the term comprehensivist.
Rather than a specialist.
If you write in comprehensivist in the computer, the spell check will not give you, there's no word for it. He just made it up, but it's a beautiful word. And he used to say to academics or intellectuals or people, dare to be a comprehensivist. Think about patterns rather than burrowing in depth into the details of everything, because the details, you could just get lost in detail.
He said, begin with the universe. Yes.
That's the name of the show at the Whitney, isn't it?
Right.
Begin with the universe.
Begin with the universe. He said to begin with the universe and come into your problem. And so that you get the full context. You can't just stay in your specialized area.
And yet that's the way academia galloped. Academia is so specialized out, and he used to say that was the way that they got the best minds that could be a threat to those who are thinking comprehensively, the
to
leaders,
put them in graduate school
the pirates,
and make them, yes.
The pirates that run the world got the best minds coming up so specialized out by setting up graduate schools. They become so specialized out on some little detail of something that they could never think about the whole and become a threat. He did say that.
Yes, exactly. Yes,
yeah, that's interesting. Yeah, I didn't mean to interrupt, but yeah.
No, not at all.
Yeah, yeah.
I just wanted to, before we run out of time, I wanted to explain the dome because it's so simple. Many people have seen the domes on children's playgrounds where the children climb on the triangular. That's really about the top fifth or sixth of a sphere. And the dome at Epcot is a full sphere.
It was, yeah.
It's held up by three supports.
Yeah,
the Montreal dome was about a 5/8 dome. In other words, you start with a sphere. For any dome that you see, began with a spherical icosahedron. Then you cut off the bottom, so it sits on the ground.
Right.
So every dome, the children's small one, the 30-story ones, they're all based on the icosahedron.
Okay, show that now. Hold it up so the camera. Give them a little time to come in on it. They can come in on it. You can.
What we talked earlier is
these are little marshmallows with toothpicks.
Right.
See, anybody could put it together.
Yeah, yeah.
That's really
good. I made
good.
these this morning.
Okay, good.
They're fresh. The tetrahedron we spoke of earlier.
Yeah.
That's the simplest structure.
Right.
That's 4 triangles. Then there are only 3 structures made of triangles. Isn't that amazing?
Okay, yeah.
The tetrahedron, this is the octahedron, which is 8 triangles.
Right.
It's 2 pyramids put together. But see, it's all triangles. There's only one other form that's all triangles. This is 20 triangles.
And what's that called?
Icosahedron.
Icosahedron?
Icosa means 20.
Is that the basic structure of the dome?
This is the dome.
Right.
So you can make this at home and show your friend this is how the domes are built.
And it's stable.
It's stable because it's triangular.
And that is what carbon-60 looks like.
Well, the carbon-60 is a soccer ball shape.
Yeah, it's like a soccer ball. Right. Well, that's like
we use a soccer ball in my exhibit as a model for carbon-60.
Carbon-60 is huge. People are going to be seeing
now,
that.
this is not nice and round yet. It has the sharp edges.
Yeah, right.
So to make a round dome, you take each triangle and you put another one in there and bring it farther out, and then a smaller one that keeps subdividing.
Yeah.
That's called different chords. And then you get each triangle, rather than flat, now has more triangles inside. So that's how you end up with the round dome.
Right, almost round. It wouldn't be quite round.
Not
really.
quite round, but more round than this. See, so that's what's amazing, that you can describe this. Now, regular mathematics works on paper, plane geometry, but there's no plane in the universe. There is no plane. There's no three balls.
Yeah, right.
There's four minimum structure. So that his synergetics, you have to have models.
Yeah,
you can model it.
Yeah, right.
And most people don't like math. Everybody didn't like math in school. We don't like math. It's because you might as well have a blindfold on. You can't handle it. You can't. It's not tangible.
Yeah.
So not only is it easier to understand synergetics with models, you have to use models because the shapes don't work on paper. You can draw them on paper, but to really handle the models, and it's so easy to make these
with marshmallows.
Right. So before we lose the time, I want to show you this. This is a jitterbug.
Okay, what is this now?
Now this is.
Let's come in, if you can come in tight on that for you, if you can. This thing on his lap. This is called a jitterbug?
Jitterbug, because it dances.
Is that in tribute to the dance of the
Yes,
time?
because it dances, right.
That was like the hip-hop or the whatever, yeah.
Now this icosahedron we just mentioned has 12 balls where all the balls are touching. And it has a stick model.
Right.
Here's another stick model.
Right.
But this shows where 12 balls are, one here, and also one in the middle. So at the supermarket, every orange, every atom, every ball, every sphere is surrounded by 12. You're not taught that in school.
It's a magic number.
12 balls surround one where they're all touching. Now, if you remove the center ball, and these are allowed to collapse, we said earlier that the square, let me just say it this way. If you put 3 pennies in the table, they make a triangle.
Yes, that's right.
If you line up 4 pennies in the table in a square, nature doesn't want to keep it square. They go like that. They turn into 2 triangles.
Okay.
A square collapses into 2 triangles.
Okay, hold it up, against the black.
Here's the square.
That's good. It's against the black. That's good. Hold it over your left shoulder.
Here's the square.
It comes up against the black,
Like if you had 4 oranges here, it collapses into 2 triangles. So that's what happens in this shape. Each of the squares turns into 2 triangles. So what happens is it starts collapsing. All 6 squares here collapse into 2 triangles each. Now we have the icosahedron.
Yeah.
Yeah. Now here, okay.
You're going to do that.
This is called the vector equilibrium.
Okay.
These are the vectors.
Okay. Right.
This shows how nature operates, how the atoms associate. This is exactly how atoms move.
This is giving us...
This is a model you can hold and feel the dance of how molecules, atoms move around.
It's jitterbugging.
It's jitterbugging.
That was a good dance.
Good name.
Yeah, Lindy. Yeah, go ahead.
So here's the magic. This turns into the icosahedron. You have to imagine the extra struts there. So that's 20. Now watch. Now this moves down to the octahedron. That's our octahedron. Could you hold this one up?
Well, hold this one.
Yeah.
Well, okay.
See, we started with the icosahedron.
I hold it here.
I started with the vector equilibrium.
Marshmallow thing.
Down to the icosahedron.
You want it over against the, well, we don't have this.
And here's the octahedron.
Okay, we want to touch through with it.
It's the same.
Okay. Yeah.
So this is two pyramids put together. This is 8 triangles. Now here's the real amazing part of it. Vector equilibrium, icosahedron, octahedron. Now you twist this. Whoops. Octahedron. Then you twist this, and it turns into the tetrahedron.
He folded it all in, right?
You fold it all in. Now we have 4 lines, 4 sticks at each corner here.
Now, those are little straws you put together with little...
No, this is dowels.
Dowels.
Now, you can go to Ace Hardware. You can get this from the Buckminster Fuller Institute.
Yeah.
Or at many stores.
Or you can
but
get it at your
you can
local
also go
hardware.
to Ace Hardware and get the latex tubing and the correct size dowel right there next to it that fits in. And you cut the tubing, and then one tube you make a hole so the other one goes in, so you get these plus signs of tubing, and you stick them in, and you have yourself any size you want. You can go all the way. You can do it also with elastic cord, but this is a lot of fun and only cost a couple of dollars, and you can have a model of how nature moves.
And look at how that works. That's
incredible.
And does that demonstrate tensegrity and so forth, or could we talk?
Tensegrity is a different thing. Tensegrity is instead every other line. It's the simplest way to say it, every other stick would be a wire.
I put this down now?
Yes. Okay. Every other stick would be a string or wire. So therefore, you'd have these tensegrity masts, they call them, where you have struts, and then they're held together by wire. So the struts seem to float. It's just an amazing thing. Now, this is his Dymaxion map.
Oh, yeah, this is amazing. Dymaxion is another term he came up with, is dynamic, what is it, maximal efficiency?
Dynamic, maximum, and ion.
Ion, what's the ion, just make it sound poetic?
I think so.
Yeah.
I think so.
Dymaxion.
But the most important thing was that actually he showed he had a house that's in the Whitney exhibit that he designed in 1929.
Yeah. Is that Wichita?
No, this is the Dymaxion house.
Oh, the Ford DeVee.
Right. So you make a hole in the ground, put concrete in, and then you place this steel mast about 4 stories high. Then you hang the rooms off of it.
Yeah, right.
And park your car underneath. It was amazing.
Yeah.
So Marshall Field's department store in Chicago showed it. And at that time, he was calling it 4D.
Yeah, that's right.
And they said, no, that's not good enough. And they got their what were called wordsmiths in those days, copywriters.
Yeah.
So they wanted to come up with something cool. So they listened to Fuller for a while. And he was constantly saying dynamic and maximum use of energy that nature uses. So they came up with Dymaxion.
Yeah, that's a good term. It's become in the language of the world now. Yeah.
Probably not a spell check yet, though.
Everything else, right. But, and among other things is I did the doctoral work in geography, so I'm very
did?
Yeah, and I'm very sensitive to this map. And they got that beautiful.
This is the first patent on a map since I want to be sure. Well, Mercator was 1490.
Yeah.
But this is the first American patent on a map. I know that.
Yeah.
A new way of projecting.
And that's the problem when you've got an elliptical spheroid like the Earth. I mean, when you get out to if you're doing it at Mercator and it just Greenland is very huge and everything because it's
a globe is correct.
Yeah, the globe is
average
correct,
globe
but
is
when
correct.
you put it on
how
a
do you
flat
unpeel off of a ball and put it down?
Right.
Well, Mercator didn't care about the distortion.
Yeah.
In fact, the United States is in the center, and then Russia is in 2 places. It doesn't make Greenland is too big.
Yeah.
This is correct.
Yeah, hold it up so they can see what it is. So
this is an icosahedron.
Right.
But it's a new way of projecting the map.
Yeah.
And you won't believe this. He did this before the domes. He just designed the map and then the domes a few years later.
It's a series
but what's
of
extraordinary is that
and,
this map in a different form, the vector equilibrium form, was in Life magazine in March 1st, 1943.
Wow, okay.
In color, on heavy paper inside the magazine.
Oh, wow.
And you pulled it out and put this together in 1943.
Wow.
Amazing.
Yeah.
He was very instrumental in planning during World War II as well.
Yes, indeed. And he was always thinking whole systems.
Always thinking the whole Earth, the whole Earth. And that was the United States' participation in both wars were the whole Earth. You know?
But does that come apart? Or not?
Yeah, I can take it apart.
Yeah, see, and
this
show them
unfolds.
How it is. And that's the way the flat map is.
Yes, this is the flat map.
See, this is the flat map that he copyrighted, and they got a large one that fills a whole big space over at the Whitney.
Yes, a basketball-sized one.
Yeah,
basketball.
At the Whitney,
yes.
Yeah. And hold it so they can see. That's the way the Earth, so that you don't have, so that all the the landforms are in more or less their proper order in terms of their size and so forth.
Exactly.
And that's what this did.
So you see Greenland for the first time, the actual size of Greenland, which is very small.
It's all and then when you put it back together, you've got the globe.
Exactly.
But this is a flat map. And that's the thing that's been used very effectively with the World Game.
Yes, the World Game started in the 70s. As we said earlier, he was actually making scenarios on how the world could be made to work.
Yes.
Because as we said earlier, we have the technology. We've had it for a number of years now.
Well, yeah, yeah.
And so the World Game used the map, as you said, and would do these scenarios as to show where's electricity in the world,
right.
where are all the where's the cattle, where are the grains.
Well, you could have this as a template in the age of cyber, whatever, and you could feed into that anything you wanted. The best mental map to have in the world, if you want to have a sense of the world, is the climatic map, because the natural vegetation fits on top of that, and that's the best map perhaps to have in the world. But then you got the political map, or then you could have steel production, you could have, you know, I don't know, pork bellies, or whatever you wanted to program into the thing. You could have distribution of population, all kinds of parameters on that. You could put that in, and then what you could do is take the measure of things. And they did World Game in a non-ideologically lardered way, thinking about how you can make everyone as, you know, thinking of the whole of the population, and get ideas of what's actually going on without all the political lardering that takes place ideologically.
His idea, as I was just going to say, was to set aside politics. You don't tell the computer at that time, you don't talk about Russia or China or anything else, you just tell the computer, where are these resources? Right. And the computer would print out scenarios for the sharing. And what now, our friend who was on your show the other day.
Yeah, which friend?
Peter Meisen.
Yes, right.
He's going to be on during your Bucky Week
presentation.
He
would have been on yesterday.
Oh, yesterday,
because we're going to air this next week.
I see.
On Wednesday. He would have aired on Tuesday, the day before this program aired.
He's been working on the project for years, which is the sharing of the electricity in the world.
The grid. We have an electronic grid, electrical grid.
Because Fuller said at any time half the world is black, and the grid and the machinery and the electricity generating stations are not being used in the dark and half of the half the world.
Yeah.
So he said to connect the whole world's energy grid, and that's what Peter's
and Meisen's very on to being able to have a renewable energy that's very au courant now, with $140 a barrel oil and gasoline prices at $4. It's $10 in Norway, I think, or something a gallon, you know, that kind of thing. And so it's making way for that. And he's saying that they can transport electricity, was it 3,000 kilometers efficiently and economically, so that
through the air?
No, through the high voltage lines. They can go. They've got such efficiencies that are developing where they can have the source of the electricity generation far from where it's actually being utilized through the grid, and they got much more effective way of doing that. And they can. And he wanted to see it being daylight, darkness, and a whole connection of a world electric grid, and we wanted to get electricity around because that's the basis of much of the modern technology, is effective use or access to effective electrical energy to run all kinds of things. If the electric energy were to go out, we would be out of luck. If it were to,
the blackouts in the big cities, sure.
The modern society is based on that so fundamentally now.
Well, that was one of Fuller's principal concepts, was the ephemeralization, doing more with less.
Could you explain that a little bit?
Well, one of his first examples was when the satellites first went up in the 50s. The Telstar. It replaced, you know, how many hundreds of thousands of tons of cable?
175,000
You know everything.
No, that is what thing he used to say.
170,000 tons?
175,000 tons of copper cable to go across the Atlantic is replaced by one satellite.
A quarter-ton satellite.
Quarter-ton satellite, and that's something that's called ephemeralization.
Ephemeralization.
That's doing more with less.
Right.
Very important principle, and that could be applied to good design principles, and that's a trend that we can see, so that with that trend we do not have to rape the environment as we did in order to get development and growth through time. And that's a very important concept, particularly on the ecological side of a living scenario that we can begin to project ahead on our world map that we're doing through a world game participation and understanding how the planet works.
Exactly.
And how it could be, good. Yeah. Educational. implications are staggering.
Staggering, yes. Well, we can't, we have to change, not only does the United States and the Western world have to change, but it's just impossible for China and India to do the same thing we did. We have to really assist by changing ourselves so dramatically. It can't happen. We cannot have China and China and India doing the same thing we did with a number of plants. The Earth can't sustain it.
That's right. If you just think about it, though, on the other hand, we've got maybe 20% of the world have been the beneficiaries of, you know, the higher standard of living, and we did things. And Mr. Gandhi used to talk about how you gentlemen are on the streetcar already, but there's all these people that you don't want to get on the streetcar. And so we don't want to say, well, the people that have not had the benefit of, let's say, growth and so forth, it's probably, Mr. Stiglitz says maybe 60–80% of the people do not participate effectively in what's able to be done. They can't clear the market or anything like that. And so that, you know, you have to be thinking about ways in which can involve them. And if you're in a zero-sum situation where you don't have enough, it's different than when you have an unutilized productive capability through good design that can be applied, that you can have the growth and the equity in justice, in a certain sense, without raping the planet to do it. And that's a transition that would come from a design science way of approaching it.
Fuller said that Malthus said that there was a finite amount of materials on the Earth and that it could only sustain a certain number. But he proved Malthus wrong because he said there's enough for everyone.
Well, he did. And that's a major, that's maybe the major paradigm shift in the history of mankind's tenure on Earth, and it's never articulated.
1970.
1970?
When we reached half the population was at a sustainable level, and now it's going higher. So it's good news in those terms.
Well, in that sense, that's something not to be just brushed over, because that is probably the major premise of his total that's the major premise that he will be remembered for.
I think so.
That we were transcending. It came out of World Game, and he had some figures that were a little bit strange. You could go, the details were wrong on population a little bit and all of that in terms of the projection from 1952. But the idea is that we were gaining in the number of people could see to be halves through time.
He said it's not a situation where it has to be you or me, but rather all, better for all. So that's the big
However,
change.
If I may, if you're in a situation where you are coming, and he projected in 1952, he copyrighted a chart and findings, and he said that in his chart, he said, by the First World War, you have haves and have-nots. You have to get definition of terms and everything. And he said we had about First World War, we got up to about 10% of the world population could be realistically seen to be haves. You know, robber barons and their bourgeois hangers-on or whatever. And then you get to a 20% by the Second World War. And he said in 1952 we had a period of 20 years of imminent crisis to all institutions that we've inherited. Zero sum, not enough. For me to gain, you have to lose. That kind of thinking, geopolitical, notions of human nature, all kinds of things are built into the thinking and the structures, of institutional structures and so forth. And that we were approaching the 50% mark, that there were in actual terms more haves than have-nots for the first time in the evolution of universal affairs or even consciousness in this part of the universe. The major transition of our time in terms of qualitative difference. It can only be compared with Copernicus and Galileo saying we do not live in a geocentric universe, we live in a thing. It's larger than that, and yet that idea is never articulated, and yet that will be the major idea that he will be remembered for. Not all the details.
I agree.
But that's the major thing, and it's not voiced enough, and it's a shame that the youth, the young people, if you ask Mr. Fuller, they will remember the 60s for, I don't know, Bobby Dylan or John Lennon or Jimi Hendrix or something like that. But they won't remember that the major figure that was giving the forward thrust of that was this fellow Buckminster Fuller.
Right. Yeah. And he pointed out that no one planned it. There was no group of people around the world that planned to get to that mark or planned for humanity to be more and more of a success. It took place because of the technology.
And remember, we inherit all those institutions out of history that are outdated. In feudal times, you had an agricultural system. You had all the royal dynastic courts in Europe were based on agriculture. You had a steam engine, you had industrialization, you had a change coming, and the institutions you inherit out of history are not adequately able to serve what the future requires, and we're in that transition now. Yes. And his is a keystone notion in terms of the ideas that can get us into a course of major transition, rather than, in a certain sense, setting off weapon systems as our leaders have been doing with regularity to steal the grain from the other or grab a power base or something. They've been doing that with regularity, and they continue in that mindset, and they don't have answers that can involve the people of the earth within a sustainable development where each person can realize their full potentiality, which is the promise of the unutilized capability now existing there, but our institutions won't let us do what we're collectively capable of doing of liberating the human spirit. Biggest problem confronting mankind, and he's had the context that he could provide, particularly if the youth would pick up on it, and that is required to make that transition, and yet we never hear it. Our politicians only talk in terms of the outdated institutions we've inherited.
Speaking of politicians, I was on...
No, don't say it that way. Tell me, I understand you were here from Chicago, and you told me on the telephone the other day you're wandering around the streets of New York like another New York City story and everything like that. You happened to run into a citizen and you had a little conversation. Tell it that way.
Well, it was President Clinton.
Oh, you told it wrong.
Oh, I said it wrong. I should have said the name right away?
You should have said you were talking to it. You said to me on the telephone you were talking to a citizen. You told him about the show, and you said
that's how I told you on the phone. Right?
Yeah, you saw the show, and it was at the Whitney, and he said, let me see if I got it right. You said, really? What's the date? When's it going to end? We're here to announce it's going to be up until the 12th, I think. We think of September. You can check with the Whitney. Major show celebrating this major figure. Every young person, every person should go there.
Yes.
He said, I really want to go. I understand that was the enthusiasm. He said, I've read much of what he's read.
He said he's read every Bucky book, and he's been a fan for 40 years.
He's been a real fan for 40 years, and that citizen of Spaceship Earth was none other than William Jefferson Clinton, the President of the United States for these many decades. Now, that's a major figure, and they should be celebrating Mr. Buckminster Fuller in a way, and why youth has let that go, and why they're not picking up on it, and why they're going down this Schumpeterian kind of thing about entrepreneurialism and all that, and have had the wool pulled over their eyes by what's been going on since then, is something that I think is worth our talking about for this whole week and conversations and so forth.
Major resurgence.
But you did that at Lexington for 70. You happened to run into him, right?
Yeah, right.
Who was
New York, right?
No, who was the guy?
What's his
Damon
hometown?
Runyon. Damon Runyon was I'm standing on Broadway and 44th, and who should come along but Harry the Horse? So you had to have a conversation. You had a president with, and he really is a fan, and he wasn't. That was not malarkey on his part.
No, I didn't. I never knew that. And I was wondering.
How did you happen to run into such an illustrious figure? Did you have a lot of people around?
No, there was just a couple of Secret Service cars, and I didn't notice. First thing I noticed was there he was standing on the step of a brownstone. I guess it was a fundraiser. But he talked to some of us for quite a while about it. And he's going to try to see the show. But I was wondering if Fuller's ideas were applied during his administration, possibly.
I don't think so. Do you? I mean, think it through. Or where are they? Do you ever hear a politician say anything other than there's not nearly enough, that we're going to distribute income only by, and they don't have an economic system? How are you going to accommodate a situation where you're understanding from your modeling and so forth that there is enough, rather than that there is a scarcity and everybody has to scurry, and for me to get ahead, you have to get behind, all of that kind of, and that's all built into notions of human nature. If ever you say something idealistic, like we can make this planet work for everyone, and with ecology and so forth, they just say you're idealistic. You just don't understand human nature is inherently greedy. And do you understand what I'm saying?
Yes, I'm sure.
So there's all these principles. You never hear the vision thing enunciated by our political or even our intellectual leaders, hardly at all. And particularly, if I may, this idea that he had, the major one. Again, I'd like to resort to that because there's a great deal of people who are interested in Buckminster Fuller, and they go into the details of tetrahedrons and all this kind of thing and everything. But the major idea is this transition from scarcity or the idea, even though if there's something a little wrong with the part, some detail in the thing,
exactly.
well, this is not right, but the idea is so huge. There were others who've come up with that too. The idea that we've come to a point where that we've transcended material scarcity as an ontological reality, or as a reality, is the major idea that will encompass his memory.
Right.
And it's never mentioned, even by the people who study him. They seem to avoid it, as though that's something.
I don't know that
why
they
do they avoid
that?
Why does humanity avoid that idea?
I don't know that they consciously avoid it. I would just say that they're just not informed.
No, I'm talking about the people who know Fuller. And they know of his thing. They avoid it for some reason, as though that's like that was a mistake he made, or that's not relevant. And yet if you think of Galileo, you don't think about all the science and the details of what he did about Jupiter's pathways and arches, and you say heliocentric, geocentric. That's what you know. That's a pattern.
Yes.
That's a pattern.
That you
and the pattern we'll get from Buckminster Fuller is the major one is with all the details of ephemeralization and this kind of stuff. But the pattern that we've seen for the youth is we've transcended scarcity. Why don't they have it on walls this high on every think tank in the world in order to test, is that possibly the case, and what are the conditions by which that could be the case, rather than ipso facto dismissing that idea, the major idea, as ipso facto absurd for some reason, because it's so inconvenient to all of the assumptions of all our institutional assumptions, including even notions of human nature, which perhaps we're going to have to revisit if we're going to deal with a human nature that is really liberated from the constriction of systems that we've transcended. Do you understand what I'm saying?
I certainly do. And I also think that the answer to how is this all going to happen, I mean, for the last 30 years, all of us have tried in each personal way, some teach, some discuss it in other ways, some apply it at their jobs and technology. But I think the answer, like the answer to everything in the world now, is the internet, is the web. The Buckminster Fuller Institute has a web, bfi.org.
Yeah, that's right.
And if you go to that, you're going to see like hundreds of individual programs that people have started on their own initiative. Fuller's big deal was take the initiative and do what you need to do to help humanity. And there's hundreds of these programs on there, and as a result, as I said, take initiative. But all these programs together are going to be able to inform the public around the world of this new, like you said, it's a whole new state of humanity, that we have the capability, with a little fine tuning and less global politics, to transform humanity into a success, as we call it, the success of humanity. And his program was called How to Make the World Work. So we're putting together a program called How to Make the World Work.
How to make the world work.
How to make the world work.
Yeah.
But I implore everyone listening and to tell your friends to go to the bfi.org.
Yeah, it's great.
And it's a beautiful site, and you'll just get swept right into it. And there's a section on how to do the synergetics, which is a kind of a hook for people. My exhibit's a hook to get people to handle it.
Kids, yeah, right.
But then my exhibit,
anybody,
my exhibit sends people off to the site to understand the rest of it.
Yeah, I do that too. I direct it to that, and we're playing these programs all week on this program, Conversations, and we're going to play a little program we made with Buckminster Fuller and myself.
What year was that?
That was in 1974, July. Just about how many years is that now?
Wow.
Do the math. Can you do the math? 74 to whatever.
Yeah.
Anyway, we did a program with him, and the whole program that we were talking about at that time, I was young, I had hair and everything like that. He was a wonderfully warm person and everything. Medard Gable was there, that was at the World Game in Philadelphia. A lot of good people were there. And what we were talking about the whole time, because I was so taken with, still am, and still wonder why it's not the prominent logo, the thing, we have transcended scarcity. That is the message. That is the pattern. That's what they be presenting. And I'll bet you have a hard time. It's like they hide it. They hide that thing that is the major thing. For some reason, I don't know why humanity does that. They don't investigate. First and foremost, we have transcended scarcity in the evolution of universal consciousness for this species called Homo sapien. We can get it, and they do not want to bring it up because it's so inconvenient to all of our institutional assumptions. I think they only let Galileo off the hook about 12 years ago for bringing us the
officially,
truth of a heliocentric universe, because they were all caught up their identities in the old way. But we're transcending that, and we haven't got time to let that sticking to those outdated ideas get to the point where we're going to unleash weapons that will destroy the whole species.
I think
and
you're absolutely
the
right.
opposite thing is equally existentially significant is this premise that he and others, Murray Bookchin and others have, that we have transcended, there is enough for everybody, and there can be an overwhelming abundance for everybody within an ecological context if we get the right economics and the right politics to utilize the unutilized capability that is there for us now. And that's the major question, and that should be the thing that is advanced as a pattern, not detail, pattern, a comprehensive pattern that he presented.
It's the best thing for corporations.
Well, it could be. It could be for everything.
So that's why it will work.
I think it would be better for humanity to become liberated than obliterated. We should liberate, not obliterate, the species.
Right.
And we have the capability, and it's there before us, and people have set patterns for us by which we can follow the liberation course. The obliterating course is to reify the old institutions that are outdated by the transformation in the spirit of the age.
Your premise I agree with entirely. It's wonderful. You're one of the few people that says it that succinctly. But it's
why do they avoid it?
The answer,
why do we
I think the
avoid
answer
that?
is we avoid it because it's unconventional. Everything is very conventional.
It's inconvenient.
It's terribly difficult to get this synergetics taught in schools. Mathematicians don't want to hear that the math we're using now, it doesn't conform to nature. They don't want to hear it. It's a bias against it.
Right.
So it's the same. My point is, it's the same kind of. It's kind of answer your question, make a stab at answering your question.
Yeah, please.
Why is that? It's conventional. It's the thing we're talking about is unconventional. It sounds pie in the sky.
Yeah, that's
Humanity can be a success. We can all work together. It sounds,
or everybody can play in the orchestra.
It can be documented with the world game.
Yeah,
that's the section. If people are interested in this particular aspect of our conversation, to check out the Whitney show, which everybody should see anyway.
Absolutely.
It's going to be gone by September. You have to be careful.
Late mid-September, I think.
To check the world game section, and there's all the description of just exactly what we're talking about. My point being, there's all the detail. There's the facts.
Don't go the detail. No, the detail, not the details we don't need. You don't want the details of where this goes. I mean, I'm sorry. That's
I'm
specialization.
saying that
you want the pattern, particularly if you're going to get youth. Youth wants a pattern, not detail. That's what education does. You get all caught up in detail. They want a big pattern that they can really grasp and understand it in 10-foot-high letters, sparkling, with flares going off. We have transcended scarcity. We have that capability because that undercuts or opens up a new possibility that all of our institutions were set up and reify the old order, which is out of date and not in touch with what the future requires. And that's what's needed to signal the youth to get really involved with this person and with the concept rather than muddling around with all the self-centered narcissism, which obviously is what the system is doing now.
If the headline is we've transcended scarcity, then when I said facts, what I meant was that it supports that. You can't just say that.